All right, we're looking at function, the word function and what it means. Now, depending on which course you're learning this in, we're just going to go over the concept of a function, how to define whether a graph is a function or not, and then we're going to look at domain and range. So this covers many topics. Specifically, we're looking at the word function. What does function mean? Well, a function is a special type of relation. What is a relation, you may ask? Well, a relation is any graph, so any graph, any table of values, any set of points, okay, any mapping notation, anything that essentially can be graphed. So we can graph all of these values. This word graph is the most important piece. That is what a relation is. It's basically any graph. All right. Now, how does that help us? Well, a function is a special type of relation. So a special type of graph, table of values, special type of set of points. What makes it special? Well, let's see. The definition of a function is where for every x, okay, every x, there can only be one y. So let's look at the definition. All right, so a function is every graph, every relation, every table of values, all of those things. So for every x, there can only be one y. Now, what does that mean? Well, let's look at an example here. I'm going to give you two sets. One is, they're both sets of points. So these are just random coordinates that you would find on a graph. Okay, random points. So one is called A, the other one is called B. One of these two is a function, the other one is not. Let's look at the definition. Stop the video, look at the examples and determine which one of these is the function, and then start the video again. All right, you're back. So hopefully you discovered that the first one is the function. The second one is not the function. It is just a relation. It's just a plain relation. Remember that both of these are relations, but the second one is not the function, the special type. The first one is a function. Why is that? Well, let's look at the definition. For every x, there can only be one y. All of these x's are different. So we don't worry about their y's because the x's are different. In this case, we have two x's that are the same. So the definition says for every x, there can only be one y. Look at their y's. They have two different y's. So these two fail the definition. So that's how you define that it is not a function. Now, sometimes you're not given a set of coordinates. Sometimes you're given a graph. How do you determine if a graph is a function or not? Well, you use something called the vertical line test. The vertical line test, or the VLT, basically says, okay, let's look at a graph. Here it is. And this graph says, okay, now what I want to do is create a line and draw this vertical line. It has to be vertical, folks, and draw it anywhere on the graph. So I can do it here, I can do it here. Anywhere along here, we take this vertical line and draw it. And what happens is this vertical line crosses through the blue graph once, and twice, 3 times. Definition says for every x, there can only be one y. Well, in this case, this x value right here has 3 parts where it crosses. It doesn't just have, so because it fails the definition, fails the VLT, it is not a function. Let's look at an example of where it is a function. So here we go. And we look at this and we say, okay, sorry, there we go. We draw a vertical line, all right, and we take that vertical line and draw and move that vertical line anywhere on the graph. You see here, folks, I move it anywhere on this graph. And how many times does this vertical line touch the blue graph? It touches it once at any given point. It never touches it more than once. So therefore, folks, this particular vertical line with this graph, we can say that this graph is a function because it passes the vertical line test, because for every x, there is only one y. Moving on, let's look at a couple of more things. Let's look at this example here. I want you to determine whether these are functions or not, and I want you to justify it. So we're going to do it verbally, the justification, but we're going to determine if this is a function or not. So I'm going to draw a vertical line somewhere on here. We're going to draw a vertical line, and let's do it in a different color so you can really, it comes out, it stands out. Let's do it nice and bright and yellow. All right. So we draw this vertical line, and we take this vertical line, and we take it across our graph. Is this a function? Yes. Is this a function? Yes. Is this a function? No. So we draw it, and then we determine where it's not a function. Is this a function? Nope, because it fails the vertical line test. And then these two we'll look at in just a minute. So I just want to go over how to do all of this. So the first one we said is a function. Okay? It's a function because it passes that vertical line. So we have that vertical line over here, and it's not a function. This one, did it pass? Yes, that is a function. The next one, is it a function? No. So we have to put an X where it crosses the graph twice. And we say, nope, not a function because it fails the vertical line test. It's only a relation. The next one, we draw a vertical line crossing through, and it touches it twice. So therefore that vertical line test, it fails it. So it's only a relation, not a function. The next one, E. Is E a relation? Is E a function? Let's look here. So we need to use the definition. For every x, there can only be one y. So here, do we have any more negative 3's as a beginning? Nope. But here we have 5, negative 6. 5 is our x. Let's see another. Oh, there's another 5, folks. So we see the same x. Does it have different y's? Oh, it does. Therefore, those two indicate that this particular set here is not a function. Okay? Next one, looking at the table of values, this is our x, this is our y. Is this a function? Well, we have different x's, so we don't have to worry. So for every x, there is only one y, and that is true. So therefore, this is a function. Okay, moving on to the next part. So letter G, here it is. Looking at this mapping diagram, each of these mapping diagram, the first one is always the domain, or x, the second one is always y, and there are arrows moving from x to y. Now the definition is, for every x, there is only one y, and this is true. Look here, each of these only have one arrow going over to the other side. Doesn't matter, it goes to the same y value. What does matter is that every x, there's only one y. And that is true, so that makes this part a function. But the second part, is this one a function? Let's see, for every x, nope. So, first one is a function. Second one is not a function. Why? Because 5 actually goes to 2 y values. And remember that the definition says for every x, there can only be one y. Now, with respect to this question, we're going to move on and move forwards from this. My expectation with domain and range is that you can do it from a graph. These particular ones involve equations. Now, you may remember how to graph these, or you may not. So we're not going to focus so much on equations just yet. In this course, we will look at equations, but right now we're going to focus on graphs. Can you tell if it's a function or not? So we're going to move forwards from this and move on to the other examples on the next page. So, E. Before we do that, I want you to know how to be able to make a convert a set of points to a mapping diagram. So that's going to be important. So I want you to be able to convert a set of points to a mapping diagram. The set of points here are -3, 5, -3, 4, 5, -6, -2, 7, 5, 3, and 6, -8. So what we do is we draw two ovals. One represents the x, the other one represents the y. And we list all the x coordinates in order, not repeating. So we're going to list all the x coordinates in order from lowest to highest, not repeating. So -3, -2, 5, and even though 5 repeats itself, we do not write that number, and 6. Now the y value, again, we use the same rules. Write the numbers in order from lowest to highest, not repeating. So we have -8, -6, 3, 4, and 7. All right? And we map -3 to 4, 5 to -6, -2 to 7, 5 to 3, and 6 to -8. And so this, folks, is what the mapping diagram would look like. Now, what you should notice is that looking at this mapping diagram, 5 maps to 2 separate y values. And because of that, we can say it's not a function. Neat, eh? All right, moving on. Look at another example. So the previous example, question number 2, I said we didn't want to look at equations, but we are going to look at graphs, and you have to be able to determine the domain and range. So note here that this first point is actually an open circle. So I forgot to put that on there, so I want you to have that on there, folks, and it's an open circle. You would be given whether it's open or closed if it begins at a specific point. All right, now we need to understand how to calculate the domain. The domain starts at what? So from domain is from left to right. It's all the x values. Domain talks about all the x values. Range talks about all the y values. And we use the domain and calculate the domain and measure it from left to right. We measure the range from low to high. So the question always is, how far left do we go or how far low do we go? Specifically, in this particular example, how far left does this graph go? Well, it starts actually at 1 or very, very close to 1. So the domain starts at 1 and it goes to infinity. So from 1 to infinity. What does that mean in terms of set notation? Well, x belongs to real such that x is, that's right, greater than or equal, not equal. Aha, tricked you. Not equal. Why is it not equal? Because it's an open circle. It's just greater than 1. So it goes from 1, starts at 1, and goes greater than 1, which means it goes to infinity. Now, the range, where how low does this function go? So it starts low as 3, and very close to 3, not exactly 3, and goes up to infinity. So y belongs to real, such that y starts at 3 and goes to infinity. That means y is greater than 3. Close the bracket. All right, moving forwards. Looking at the next one. Now this one has some extra things that I'll make sure is drawn for you for your test or quiz. You'll have a dotted line going horizontally and a dotted line going vertically. Why? Well, the dotted line means it is called an asymptote. That asymptote, okay, is a special line kind of like the border where it doesn't get crossed. You cannot cross that asymptote. The graph does not touch it. It gets really close to it, but it doesn't actually touch it. So this particular graph starts as far as negative infinity, and then it comes this way, and then it doesn't touch this line. It looks like it's getting close to it, but it actually doesn't touch this line. What number is that? That's right, it's -3. It doesn't touch -3, but then on the other side it gets really, really close to it, doesn't touch it, remember, and then it keeps going to positive infinity. So from left to right, goes from negative infinity, doesn't touch -3, and goes on to positive infinity. So how do we write that? Well, we write it as the domain is x belongs to real such that it's everything but the value, that's right, -3. So it doesn't touch -3, but it touches everything else. Same thing for range. Let's look at range. Negative infinity is the lowest it goes, all the way up to, oh, it gets really, really close to this 0, but doesn't actually touch it. Then it jumps to the other side, gets really close to the 0 again, but then it goes all the way up to infinity. So we measure from low to high. So y belongs to real such that y does not equal 0. And that, folks, is the answer to this particular question. Moving on. All right, let's look at this. Is this one a function? Now, if I was to run a vertical line, let's take a vertical line here and run it across the graph. And this line, this particular line, does it touch anywhere on the graph more than once? No. Therefore, this particular graph is a function. So, now what we want to do is state the domain and range. So, domain is going to be, how far left do we go? Well, it stops at a specific point. What point is that? We can assume it's a unit scale when there are no numbers given. So, goes from -5. So, x belongs to real. Now, this is weird because it starts at -5 and then it ends at -1. Then it does a jump over and starts again at 0 and goes on for infinity. So again, from left to right. Starts at -5, goes up to -1, jumps over, starts at 0, and goes to infinity. So -5 to -1, jumps back down to 0 to infinity. So x belongs to real. This has two parts. X is between -5, including the -5, all the way up to -1, or it jumps on the other side from 0 to infinity, which means x is greater than or equal to 0. The second piece is how low does it go? It starts at 0, and some of you might be thinking, okay, it ends at 3 and then jumps again. But wait, folks, look over here. This 0 continues over here, so the y value doesn't actually do any jumping. This side says it's going to keep going forever and ever. So that means y is just greater than or equal to 0, and that's it. All right, G. What we're looking at G is, I want you to understand that right here, this curve is actually not vertical, as you can see here. It actually is a curve, and we're going to be studying this curve in grade 11 university math. In grade 11 mixed, we'll probably just see the graph, but in grade 11 university, we do look at this particular graph. Either way, this graph is actually a function, okay? And it's a function, and the domain for this is the shortest fairy tale ever said. Once upon a time, x belongs to real, and we're done. That's right, because it goes from -infinity to positive infinity. And then range, well, hopefully you're seeing that, yep, there it is again, that shortest one. And looking here, we have y belongs to real, so it goes from -infinity all the way up to positive infinity, because there is an arrow at the other end of that. Okay, one more. looking at this example, is this a function? Draw the vertical. Yes, it passes the vertical line test. For every x, there's only one y. Now we have to state the domain and range. So the domain for this function is x belongs to real, and that's it, because it goes from negative infinity to positive infinity. There is no break or stop. And for the range, this is the lowest it goes. Everything else is higher than that. So the lowest it goes is negative 3. Y belongs to real, such that y is greater than or equal to negative 3. And that, folks, is the definition of the function. All right. And that's the end of the video, folks, and the lesson. Hope this helps. Take care. Have a numerical day.